Hello everyone. This is the submission video for the Project 5X Clarity that I've made as a part of the Builders Edition Clarity Hackathon. Starting off with the inspiration, I have always wondered why didn't people try to create a smart contract compatible language for the existing blockchain network rather than going all out and creating something like Ethereum and Solidity for that. I agree that blockchain has its own weaknesses, like its proof of work consensus might be very energy demanding and it's quite slow. But when I came to know about stacks and their language clarity, I was very much intrigued to see how they tackled the problems of integrating with the main blockchain network. Um, I was surprised to see the mechanisms that they have applied to tackle those problems, like proof of transaction and microblocks, to tackle the speed as well as energy problem. Uh-huh. Nah, at least this, at least this, I was immediately hooked to this and to the fact that I spent around 40 hours over a span of 3 days getting and being caught on the clarinet. So I started out building 5 practice projects following the documentation as well as the book that was provided, and after that I went on to build my own 5 other smart contracts as a part of the submission. The first one of it being a simple transaction. Here, a simple transaction can happen. The person who deployed the contract can send amount send a particular amount of tokens to a different address. It's all that there is, and it also handles all the edge cases with error codes properly. Next, we have a fundraiser. Here the smart contract acts as a DAO, and people can fund it. And the smart contract will hold the funds for a while. And once the fundraiser is over, the person who created the smart contract can transfer the funds to a beneficiary. Again, all the error codes has been properly handled, and the testing has been done as well, also for the simple transaction. Next, we have auction. Here, the smart contract deployer is the auctioner, and they can set an auction item URL. Here, instead of having images, I thought of giving it a URL so that the URL can contain a lot more than images. It could be a video, it could be a text, or it could be anything what the auctioner wishes. Then, once the URL has been set, the auctioner can also set the minimum bid, the starting bid, and from then on, the people can come in and give the bids. It just keeps track of who's the maximum bidder at all times. And once the auctioner closes the auction, the maximum bidder alone will be able to purchase the item after that. This also handles all the edge cases and errors properly, and it has been thoroughly tested as well. Another important thing to note here is it's better if our URL is an IPFS URL so that it's immutable as well as decentralized, very much suiting our own needs. Next, we have a legal agreement. Here we have a promiser and a promisee. The promiser is the person who deployed the contract, and he can again set the document URL, the agreement URL. The agreement URL, again, it would be better if it was uploaded to IPFS and that URL was given because of its immutability again. And next, we have that anybody could get the document URL to, to see, and then they can agree to it. Once a person has agreed to that document URL, they become the promisee, and no more people can agree to it anymore. It's between a single promiser and a promisee, and this smart contract establishes that agreement relationship between them. Finally, we have the delivery tracking. Here we have the sender, who's the origin of all this, and the contract deployer. He he can choose to send the package to a warehouse. They are like middlemen in the process of sending the package to the final receiver. And talking about the receiver, the contract deployer, before he can send it to any warehouse or something, must first set the receiver. And once the receiver is set, it can't be changed further. Only only the receiver can stop the forwarding of the package. The middlemen, they themselves can't change the receiver, or they can't do something if they don't have the package with them. Like, let's say there are three middlemen, A, B, C, and there is a sender and a receiver. So the sender sends the package to A, but if B tries to do something to the package, they'll get a not owned error because B doesn't have the ownership of it. Only A can do something with it. So that's about the delivery tracking smart contract. And to conclude, all these contracts have been thoroughly documented, tested, as well as they all have their own explanation explanation videos in the playlist available in my YouTube channel. The links for which has also been added to the submission, and the code and everything is also available in the GitHub repository over here. That has also been shared. What's some of the challenges that I faced? Some of the challenges that I faced might be working with sequences, the sequences type, and I think there could be more documentation for it so that it enables everyone to create much more powerful smart contracts using the Clarity language. And I'm currently working on using these Clarity contracts that I've made in actual DApps using the libraries that Stacks provide. And I'm currently in the process of learning it. But that's all about the five contracts that I've made, and thank you for your time.